Hello everybody, happy Monday. Hopefully you guys are doing well. With all that's going on, I really hope that you guys are staying safe, you're staying isolated at home, and being as safe as you can. This is kind of a crazy world that we live on right now. I don't think I've gone outside since like Tuesday of last week, so almost like a full week since I've been outside. It's been pretty crazy, and I hope you guys are staying safe. I'm definitely concerned about you guys. You guys are in my prayers, and I pray that you guys are able to stay safe and stay healthy. So, as well as your families as well. So, we on Friday you just took the quiz, the mid-chapter quiz for chapter 14. If you haven't taken that yet, you gotta make sure you go and do it. You have 3 days of e-learning so far. This is our 4th day. Hopefully, you're staying caught up. Okay, for those of you that aren't, make sure that you're staying on top of it. Now that we're going to be out for even longer period of time, till at least May 1st, it's going to make it even more essential that you guys stay on top of your assignments every day. Okay, and that you guys are emailing me with any questions that you have. Okay, so today we're going to actually do lesson, let's go over to PowerPoint here. This is lesson 10.4, which is solving a radical equation. So let's go ahead and jump into it. Our objectives for today are to solve equations containing radicals, and then to identify extraneous solutions. Okay. Now the expression for D, and we didn't do the solve it, so we're going to skip that part. Okay, but a radical equation is an equation that has a variable and a radicand. Examples include radical x minus 5 equals 3. That's an example of a radical equation. Okay, radical x minus 2 equals 1. It's got a radical symbol, therefore it is a radical equation. Okay, when the variable is in the radicand, so you've got an x inside the radicand, that's a radical expression, right? Or a radical equation. To solve a radical equation, you get the radical by itself. We solve it just like every other normal equation. You got to make sure you square both sides. That's how we get rid of the radical, is by squaring both sides. Okay. You also got to remember that the expression underneath the radical needs to be non-negative. It's always got to be positive. You can't take the square root of a negative number. All right, so problem 1, solving by isolating the radical. Now this is kind of the first lesson that we're doing via e-learning. So what I'm going to do is I'm going to go through each problem, and then I'm going to have you pause it for the got it problems, because I want you to really make sure you're doing these on your own in your notebook. Remember, on tests and quizzes, you can use any notes that you've taken over these videos, any examples that we've done together in class, or in these videos you can use. So make sure you're taking good notes, you're writing each of these examples down, because you will be able to use these as a reference when it comes to the test or quiz. Okay, so first thing is, what is the solution of radical x plus 7 equals 16? Okay, first thing we want to try and do is we want to get the radical expression by itself. To do that, we're going to subtract 7 on both sides. Okay, this is going to cancel out here, and it gives me radical x equals 16 minus 7, which is 9. Now to get rid of this radical sign, we want to square both sides. Okay, radical x squared just gives you a regular x, and then 9 squared is equal to 81. Okay, so x here is equal to 81. What we could do then is we could plug it back into our original equation. The square root of 81 is 9, and then 9 plus 7 is 16, so our answer checks out. Okay, what I want you to do is go ahead and do the got it here on your own. Go ahead and pause the video, solve it, and then I'll give you the answer here in just a second. Okay, hopefully you took time to pause it and actually go through the question on your own. If you haven't, pause it now and go ahead and try it. Okay, first thing you're going to do is you're going to add 5 to both sides. This gives you radical x equals negative 2 plus 5, which is 3. And then you're going to square both sides, and you get x equals 3 squared, which is 9. Okay? All right, problem 2, using a radical equation. The time t in seconds it takes for a pendulum of a clock to complete a full swing is approximated by the equation t equals 2 radical L over 3.3, where L is the length of the pendulum in feet. If the pendulum of a clock completes a full swing in 3 seconds, so the full swing in 3 seconds, what is the length of the pendulum? Okay, so we're trying to solve for L here basically. Okay, T is given. It says the full swing is 3 seconds, so we're going to plug 3 in for T. Okay, and then we have 2 radical L over 3.3. Okay, again, I'm sorry, my handwriting here is not very good. It's hard to write with a mouse. You'll have to forgive me with that, but we'll do our best. Okay, first thing we want to do here is we want to isolate our radical here. So to get rid of our 2, we just need to divide by 2 on both sides. This cancels out our 2 and it leaves the radical L over 3.3. Okay, so 3 over 2 is 1.5, and then that's equal to radical L over 3.3. Okay, now we want to get rid of our radical sign. So we're going to square this side and we're going to square this side. So we need a calculator for this. Okay, what I want is I want 1.5 squared. So we're going to plug that in. 1.5 squared is 2.25. 2.25. And then that's equal to, once we square this left side, that makes our radical go away. So we've got L over 3.3. Okay, last thing we want to do then, to get rid of this 3.3, we're going to multiply both sides by 3.3. So we're going to do 3.3 on both sides. So then we're going to times by 3.3. And it gives us L equals 7.425. And it does say round to the nearest tenth. So since this 2 is going to round our 4 down, so it's basically our length is equal to approximately 7.4 feet is our label. So 7.4 feet. Okay? All right. What I want you to do is I want you to go ahead and solve this one on your own. It says, how long is a pendulum if each swing takes 1 second? So again, instead of 3 seconds, the swing is 1. So you're going to plug 1 in for T here. Okay? So T equals, let me just write down this equation again. T equals 2 radical L over 3.3. And basically it says, how long is the pendulum if each swing takes 1 second? So you can take 1 and plug it in. So go ahead and see if you can solve this on your own, and then pause it, and then we'll solve it here in a second. All right, so hopefully you took some time to solve this. Plugging 1 in, you're going to divide by 2 first, so you get 1 divided by 2 is 0.5 equals radical L over 3.3. Okay, now you're going to square both sides. So 0.5 squared, let me just plug this into my calculator real quick, gives us 0.25 equals L over 3.3. And now we're going to multiply by 3.3. And that gives us a length of 0.825. So we'll round to 0.8 feet. Okay? So hopefully you did well on that one. You're able to make sense of this. Problem number 3, solving with radical expressions on both sides. So it says, what is the solution of radical 5t minus 11 equals radical t plus 5? So here we've got radical signs on both sides of the equation. So we're actually going to square both sides like normal. And by squaring both sides, that gets rid of both radicals. So we end up with 5t minus 11 equals t plus 5. Now we want to combine like terms. So we'll subtract t on both sides, and then we'll add 11 on both sides. So basically we have 5t minus t is 4t. And then on this side we've got 5 plus 11, which is 16. Then we divide by 4 and we get t equals 4. Okay, go ahead and pause the video. I want you to go ahead and do the got it there on your own. Okay, hopefully you paused it. You took some time to solve this equation. We're going to square both sides first. Okay, let's see how you did. We should have 7x minus 4 equals 5x plus 10. Okay, we'll subtract 5x on both sides, and then we're going to add 4 on both sides. Okay, so that cancels out my 4's, cancels out my 5x's. So this gives me 2x on the left side, and then that gives me 14 on the right side. Then we'll divide by 2 and we get x equals 7. Okay. Should I have you raise your hands if you got that one right? Yeah, go ahead and raise your hand. Raise your hand. Did you get it right? Yeah, I got it right. Thanks, Mr. Yoder. Good job. All right, so when you solve an equation by squaring each side, you create a new equation. The new equation may have solutions that do not satisfy the original equation. So let's say our original equation is x equals 3. If you square each side, you get x squared equals 3 squared, which then gives you x squared equals 9. Okay. Now the solutions for x squared equals 9 are actually 3 and negative 3, right? 3 squared is 9, and negative 3 squared is also 9. Okay. In the example above, negative 3 does not satisfy the original equation, right? Our original equation was x equals 3. Negative 3 doesn't equal 3. Okay. That does not satisfy the original equation. So it is considered an extraneous solution. An extraneous solution is an apparent solution that does not satisfy the original equation. Always substitute each apparent solution into the original equation to make sure you check for original or for extraneous solutions. So 3 works, negative 3 does not. That's extraneous. All right, so problem number 4, identifying extraneous solutions. What's the solution of n equals radical n plus 12? So to get rid of our radical here, we're going to square both sides. So we end up with n squared equals n plus 12. Okay. Then what we're going to do, we're going to actually combine them all. In order to solve this, this is a quadratic equation here, so we're going to need to combine them all on the same side. So we're going to subtract n and subtract 12. So n squared minus n minus 12 equals 0. To solve this, then, we're going to need to factor this. Okay, so what we need is we need factors of negative 12 that add to negative 1. Right? Well, our factors for that are going to be negative 4 times positive 3. So it's going to be n minus 4 times n plus 3 equals 0. Okay, and that means that n is equal to positive 4, right? 4 minus 4 is 0. And negative 3. Negative 3 plus 3 equals 0. Okay. Now what we want to do is we want to check for extraneous solutions by plugging these back into the original equation. So first we'll do 4. Okay, we want to know if 4 plus 12 is 16. Square root of 16 is 4. Okay, let me erase some of this stuff so it's less confusing. Okay, so 4 plus 12 is 16. Square root of 16 is 4. That equals 4. That's what we want. Negative 3, though, negative 3, and then negative 3, and here, negative 3 plus 12 is 9. The square root of 9 is a positive 3. Okay, so negative 3 does not equal to positive 3, so that means that negative 3 here is an extraneous solution, so our only solution is 4. Okay? All right, so what I want you to do is go ahead and do this one on your own. Again, remember, anytime you get one of your solutions doesn't work, that's considered an extraneous solution. So you want to make sure you plug them back into the original equation then once you find the solutions. Go ahead and pause the video now and see if you can find them. Okay, hopefully you took some time and solved these. I'm going to go ahead and square this one. Okay, negative y squared becomes a positive y equals, sorry, positive y squared, I should say. And then square root of radical y plus 6 gives you just y plus 6. Okay, we're going to combine them on both sides. So y squared minus y minus 6 equals 0. And now we want factors of negative 6 that add to negative 1. Okay, well our factors are going to be negative 3 and positive 2. So y minus 3 times y plus 2 equals 0, which means that y has to equal 3 and negative 2. Okay, now we want to plug these back in to see if they work. So 3 plus 12 is 15. Okay, the square root of 15 is like not 3, right? If we did, hang on, I think I might have made a mistake here. Did I? Oh, I'm looking at the wrong thing. I want to look at these down here. Sorry. Not these. I want to plug 3 in down here. Sorry, I want to plug 3 in down here. I was looking at the wrong equation. Okay, so 3 plus 6 is 9. Square root of 9 is 3. This, however, is negative 3, right? Because this is negative y. So 3 is actually not a good solution. Okay, if we plug in negative 2, negative 2 plus 6 is 4. The square root of 4 is 4. Okay, if we plug in negative 2 for y here, negative 2 is a positive 2, which means that negative 2 is our solution. Okay, do you guys catch how that worked? Let me erase this stuff just to kind of get a little bit of clarity again. So when we plug in negative 2 for y, right, you already have this negative sign, so negative 2, two negatives make a positive. So positive 2 equals square root of 4, right? Because negative 2 plus 6 is 4. Square root of 4 is 2, so you get 2 equals 2. Okay? Last problem. Identifying equations with no solution. Sometimes you can only get extraneous solutions after squaring each side of the equation. In that case, the original equation has no solution. So basically, if the solutions that you find are all extraneous, that means there's no solution. Okay? So first, what we're going to do, we're going to subtract 8. Whew, that was a good finger crack there. Subtract 8 on both sides. Okay, so we get radical 3y equals 2 minus 8, which is negative 6. Right away, before we even square both sides, can you ever get the square root of something equals a negative? No, never. Okay, but let's go ahead and humor it here, and let's finish this off. We'll square it. We get 3y equals negative 6 squared, which is 36. Divide by 3, you get y equals 12. If we plug this back in, radical 36 is, 3 times 12 is 36. Radical 36 is 6. And then 6 plus 8 is 14. 14 does not equal 2, so as we thought, we get no solution. Okay? No solution. So anytime you get all of your solutions are extraneous, that's where you get no solution from. Okay? So what I want you to do is I want you to go ahead and solve this one then on your own. Go ahead and pause the video, and I'll come back with you in just a second when you're done. Okay, so what we're going to do here is we're going to subtract 6 on both sides, and we get negative radical 2x equals 10 minus 6, which is 4. Now we've got this negative here. To get rid of that, we're going to multiply both sides by -1. And you get radical 2x equals 4 times -1, which is -4. Okay. Now again, you can see the square root of something equals a negative. You can't have that. So this is going to be no solution. If we square both sides, though, just to check, we get 2x equals -4 squared, which is 16. And then x equals 4. We plug that back into the original equation. 2 times 4 is 8, right? And then the square root of 8 is going to be like 2 point something. 6 minus 2 point something is going to be like 3 point something, which does not equal 10. Okay, so we do get no solution. Okay. And then B, how can you determine if that equation radical x equals -5 does not have a solution without going through all the steps to solve the equation? Basically, anytime you have a radical that equals a negative number, that just means it's going to be no solution. We kind of already talked about that already, but anytime you have a radical equals a negative, that tells you already there's no solution. So you don't really need to finish it. Okay. All right, so that's all we have for today. Hopefully you were able to follow along okay. If you have any questions, let me know. Your assignment is posted on Math Excel. It's the 10.4 homework. Again, if you have questions, make sure you email me. Stay in contact with me. I am happy to answer any questions that you might have. Please do not hesitate to reach out if you have questions. That's my job to answer them. I don't want you to think that you're all by yourself on this. You may be isolated physically from me, but you don't have to be electronically. Feel free to email me with any questions that you have, and I'm happy to answer them. Okay? Have a good day, guys. Continue to stay safe.